Hello everyone, I am Priya, the Assistant Professor of BSH in the Department of Mathematics. Today we are going to discuss the ordinary differential equations topic, and this topic is we apply the method of variation of parameters and using the linear second order differential equation with constant coefficient of non-homogeneous functions. And then let us first we introduce the linear second order differential equation with constant coefficient of non-homogeneous. And the equations is that d2y dx2 plus p1 dy dx plus p2y equals to r. Here p1 and p2 are constants. p1 and p2 are constants. And capital R is functions of x only. Functions of x only. Now we solve this differential equation, then we get the two linearly independent solutions, and the solutions are y1 and y2, and satisfy these differential equations of homogeneous of second order. And these equations are d2y1 dx2 plus p1 dy1 by dx plus p2 y1 equal to 0, first one, and second one is d2y2 by dx2 plus p1 dy2 by dx plus p2 y2 equal to 0. Then we get the general solution of homogeneous linear second order differential equation. And at first we know that CF means the complementary function. So the complementary functions is of the form is y equal to c1y1 plus c2y2. Here y1 and y2 are the two solutions this satisfy the homogeneous linear second order equation, and c1 c2 are arbitrary constants, and it is very important because here c1 and c2 are the arbitrary constants. Now the solution of the general solution of this equation, this non-homogeneous differential equation. So we get u1 and v1 are the functions of x. u1, the formula is minus integration y2 times, here not x values, write this, minus y2 times r divided by w, and this here y1 times r divided by w times dx, here times dx. Here r is the functions of x of this non-homogeneous linear differential equation, and y1 y2 are the solutions, and w is the Wronskian. What is the Wronskian? So Wronskian is that determinant of y1 and then second y1 dash derivative, first derivative, and y2 is y2 dash derivative, and this Wronskian value is y1 y2 dash minus y2 y1 dash, and this is not equal to 0 because here y1 and y2 are linearly independent solutions. y1 and y2 are linearly independent solutions of the non-homogeneous differential equation. Now in our questions is that the equation is d2y dx2 plus 4y equal to sin 2x. Here at first homogeneous equations we solve the complementary function. Let y equal to e to the power mx, where m not equal to 0, we have trial solution of this equation of 1. This is the number. At first the auxiliary equation of this equation, auxiliary equation is m square plus 4 equal to 0. So we get the two values of m minus 2y, 2y. And the complementary function of this formula is y equal to c1 cos 2x plus c2 sin 2x. So complementary function we get this homogeneous differential equation. Now we get the general solution of the non-homogeneous differential equation for this particular integral. So particular integral, at first we solve u1 and v1. u1 is equals to this formula we apply minus y2 times r divided by w. At first we calculate the Wronskian w. So two linearly independent solutions we get here, cos 2x and sin 2x. So Wronskian is values is 2 and 2 is not equal to 0. So satisfy these two solutions are linearly independent. Then u1 is equals to minus integration sin 2x times y2, that means sin 2x divided by w, that means Wronskian's values 2. And after this calculate the integration sin square 2x, and here we apply 2 by after this multiply by 2 and this divided by 2, and then this is the formula. 2 sin square x means 1 minus cos 2x. We all know this formula in our HS. So we apply here 1 minus cos 4x and integration with the we get the values minus 1 by 4 x minus 1 by 4 sin 4x. And then second function is v1, and v1 is equals to integration of cos 2x sin 2x divided by 2. Also as we apply the formula, Wronskian values is to be put, and then our second formula in our HSS, we know that 2 sin x cos x is equal to sin 2x, and here 2 sin 2x cos 2x, that means sin 4x, and we integrate these values and we solve, we get minus 1 by 16 cos 4x. Now the particular integral is that u1 y1 plus v1 y2. So we substitute these values and we get this result, and the general solution is that whole y homogeneous plus non-homogeneous, and we get this general solution complementary function plus particular integral. Complementary function is c1 cos 2x plus c2 sin 2x plus, and this particular integral we calculate minus x by 4 plus 1 by 16 times sin 2x cos 2x minus 1 by 16 cos 4x. Here we write, it must be right where c1 and c2 are arbitrary constants. Now in this process we apply the method of variation of parameters, and we get this the result of linear second order differential equation with